Hey, it's Mr. Shrum, and we're going to finish up the atoms and elements tutorial. We left off right at the atomic model, which is the last section of this tutorial. But we're going to talk about what is a model. So the image to your left show a model airplane and a real plane. The model looks very much like a real plane, but not exactly like it. A model that represents an object, event, or some type of phenomenon makes it easier to understand that item. And we use different models of the same object depending on what we want to know. And an example of this is we use a simple model of our solar system to study the different bodies in it. We use a complex model to study how those bodies affect each other's orbits. However, no one model is able to show all aspects of the object, event, or phenomenon that it represents. You need multiple models that are slightly different. Some models show things that we can't see. For example, we can't see inside atoms. Scientists created a model of their structure, and the model helps us understand how atoms are made and how they act. But the model of the atom has undergone many changes over time as well, and it gets more and more accurate and helpful. And we're going to look at those different models and learn more about those models since we've talked about them before. We talked about the Bohr model of the atom, C, earlier in the lesson. So this picture C is the Bohr model. Bohr was not the first person to develop a model of an atom, and he was not the last. This is the most recent model with the electron cloud model. However, we still use Bohr's model, C, today because it's useful for many applications of chemistry. It shows the levels of electrons in an atom and the valence electrons. Valence electrons help us predict which elements will react together to form compounds. So it will help us predict which elements act with others and what will actually happen. They also tell us what kind of bonds will form between atoms. So though it's not the most accurate model, it is very helpful in certain situations. Many models in science change over time. They change when scientists discover new information after conducting investigations. What are some atomic models? Who were the scientists that developed them? What investigations did they conduct? Watch the video on the next screen to answer these questions. Let me make sure I'm sharing the computer sound. That'll work. Turn up the volume a bit. Okay. Turn on the captions. And we should be good.
The idea that matter is made up of smaller particles started with ancient Greek philosophers. The word atom comes from the Greek word atomos, which means uncuttable. The philosophers used the word atomos to refer to the simplest, purest part of matter that couldn't be reduced any further. Now, they weren't exactly correct, and what they thought of as atoms isn't what we know atoms to be today. It wasn't until the late 1700s that atomic theory began to take shape in the modern sense. A chemist named John Dalton observed that water could evaporate and become a part of air. He proposed that air and water must be made of different particles for them both to occupy the same space. From this evidence, Dalton created a model of an atom. He supposed that an atom was one solid particle made up of all the same material. Unfortunately, Dalton didn't have all the facts, so his model became obsolete. A few decades later, an English physicist named J.J. Thomson built on Dalton's theories and discovered through research that atoms contained electrons. Thomson's model is called the Plum pudding model because it resembles a bowl of plum pudding. It shows atoms as spheres of positively charged matter that are embedded with negatively charged electrons. Thomson knew that most atoms have a neutral charge, so he also knew that the positive parts of the atom had to be canceled out by the negative electrons. Thomson's ideas advanced the study of atomic theory, but he didn't have all the facts either, so his model was inaccurate. Some years later, a New Zealand physicist named Ernest Rutherford conducted some experiments in which he and his students bombarded gold foil with positive ions. They discovered that some of the particles bounced back. This discovery led Rutherford to conclude that an atom was made up of a small nucleus of positively charged particles that reflected the ions in the gold foil experiment. Rutherford also believed that the rest of the atom was nothing but empty space, which allowed some of the other positive ions to pass through the gold foil. From Rutherford's discovery, scientists all around the world learned that the atom wasn't one singular particle. Atoms are made up of smaller subatomic particles. However, Rutherford didn't have all the facts either. Other scientists added to his discoveries, and as scientific study advanced, the science of the atomic model changed. Around the same time, a physicist from Denmark named Niels Bohr was also studying atomic theory. He knew Thomson and studied under Rutherford. He found electrons grouped into concentric orbits around the nucleus, which he called energy levels. Yet Bohr's model was also incomplete and inaccurate, because he also didn't have all the facts. The Bohr model couldn't account for the fact that electrons are both a particle and a wave. So a few years later, a physicist named Erwin Schrodinger started trying to solve this problem. Schrodinger developed a mathematical equation called the Schrodinger Equation. It accounted for the wave energy of an electron and allowed physicists to estimate the location and momentum of an electron. Many people didn't accept Schrodinger's equation. Werner Heisenberg, a German physicist, explained why the equation was correct, and people accepted this new model of the atom. This discovery led to a new atomic model that takes into account the wave nature of electrons. The Schrodinger-Heisenberg model demonstrates that electrons are found in a cloud-like cluster around the nucleus rather than in the levels laid out by Bohr. As time goes on, scientists continue to learn more about physics. They debate and review knowledge that's collected by other scientists and use these observations to shape the current understanding of our universe.
Yeah. So we saw how the atomic model changed between 1808 and 1926. Theories and models are never final. That's the thing about science, is it's a continuing process and search for the, if not truth, the truest way to describe our reality. It can always be changed if new information is found. To improve theories and models, scientists test them. They also debate the meaning of the results with each other. Scientific knowledge is the result of this testing and debating within the science community. The story about the development of the atomic model shows how scientists improve explanations and models. They use all the information that's available to them at the time. And so we're asked, over time, scientists have changed the atomic model as new information has become available. Give an example of evidence from the video that led to a change in the model of the atom. Oh, well, let's get the answer key up. So Madame Curie studied radioactive substances for many years. In 1902, she introduced a theory that a few kinds of atoms can disintegrate and eject energetic particles. She was convinced that atoms aren't made of one particle. In this way, Dalton's atomic model changed. In 1904, Joseph John Thomson discovered electrons while he was studying cathode rays. He concluded that a stable atom has negatively charged particles and an equal number of positively charged particles. These characteristics make an atom neutral in charge. So, an example of evidence from the video. I was thinking more along the lines of the gold foil experiment, in which they were bouncing alpha particles off of a nucleus, but those answers work as well. And then that brings us to the summary of the entire lesson, which we pretty much just did in that video. So I hope you learned a little something about atoms, elements, periodic tables, things along those lines. And if you have any questions, email me, message me in Canvas, and I will help you out as much as possible. And I hope you all have a great weekend, and I will see you all later. Bye-bye.